So today we're going to be learning about binomial distributions and expanding binomials. So this means that if we have a binomial, which would be like a plus b or a plus 5, and then we're taking it to some sort of power. So looking at this first picture here, we have a binomial and we're taking them to various powers. If we take a plus b to the 0 power, remember that anything to the 0 power is 1. So when we expand it, it just equals 1. Then we have a plus b to the first power, which is just a plus b. And then we're squaring it, which we would have to FOIL to get this. And then we're cubing it, and it expands to this. And then we're taking it to the fourth, and it expands to this. So if you notice, as the degree of the exponent gets higher, there's more and more work involved. So what we're going to look at today is a shortcut, or an easier way to expand these binomials. And it's called the binomial theorem. And the first way that we're going to learn how to use the binomial theorem is using Pascal's triangle, which is right down here. Now, Pascal's triangle will give you your exponent, or your coefficients, sorry. It'll give you your coefficients for your binomial when you're expanding. So if we look at Pascal's triangle and our examples up above here, we have row 0, which would be like taking something to the 0 power, and our coefficient is 1. If we're taking something to the first power, so a plus b to the first, our coefficients are 1. And then squaring, cubing to the fourth, and so on. So how to get Pascal's triangle, you're taking, each row starts and ends with 1. So your first coefficient will always be 1, your last coefficient will always be 1. And what you do is you take the previous row and you're going to add the two terms to get the next term. So for row 4, to get row 5, we take the 1 plus the 4, and you get 5. You take the 4 plus the 6, and you get 10. 6 plus 4 is 10, and 4 plus 1 is 5. So when we're looking at the 5th row and we're trying to get the 6th row, you start with your 1, and then you take 1 plus 5 from the previous row, and you get the 6. 5 plus 10 gives you the 15. 10 plus 10 gives you the 20. And 10 plus 5 gives you the 15 again. 5 plus 1 gives you the 6. And then you end with 1 again. So that's how you generate Pascal's triangle. That's how you get the numbers that give you your coefficients. So now we're going to use Pascal's triangle to expand a binomial. So if we look at problem 1, problem 1 is already expanded for us, but it's asking for us to expand a plus b to the 6th. Now, what does a plus b to the 6th actually mean? That actually means that we're multiplying a plus b 6 times. So we have the quantity a plus b times the quantity a plus b times a plus b, so on, 6 times. So how would we do this by hand? We'd have to FOIL these two, and then once we got that, we'd have to multiply by a plus b again, And then once we got that, we'd have to multiply by a plus b again. and again, and again. So we'd have to multiply 6 different times to find a plus b to the 6th. So using the binomial theorem and Pascal's triangle, we can do that a lot quicker. And it makes it a lot easier than multiplying it out like this. So in problem 1, it shows, it already has it expanded for us. And if we're looking at Pascal's triangle up above, the row that you want to look at is the row that's your power. So we're going to the 6th, so we want to look at row 6. So our coefficient should be 1, 6, 15, 20, 15, 6, and 1. So is that what we have? We've got a 1, a 6, a 15, a 20, a 15, a 6, and a 1. So those are our coefficients when we expand it. Now we need to talk about what happens to the variables, or your different terms in the binomial. Your first term in the binomial is going to start out with whatever power you're going to. So in this case, we have a, and it's going to be going to the 6th. So we have a to the 6th. And then after that, it decreases one until you get to 0. So you start out with a to the 6th, and then you'll have a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1, and a to the 0. Now your second term, in this case the b, starts out at a power of 0 and will increase by 1 until you reach the power that you're going to. So in this case 6. So b starts out as b to the 0, then you have b to the 1, b squared, b cubed, b to the 4th, b to the 5th, and b to the 6th. And these are all multiplied. Each term in your expansion are multiplied. So these aren't difficult, it's just you have to keep track of what is what's going where. So after you do this expansion, then you're going to want to simplify it. So we have 1 times a to the 6th times b to the 0. What's b to the 0? 1, because anything to the 0 is 1. So we have 1 times a to the 6th times 1. So that just gives us our a to the 6th. The next one is already simplified for us. We can't really simplify that any further because we have 6 times a to the 5th, b to the 1st, which is just b. And you're going to simplify each one of these. And this is what it ends up expanding to in simplified form. So we're going to actually do an example on the next page. So our example is x plus 5 to the 4th. And we're going to use Pascal's triangle to expand this binomial. So first, we should find our coefficients using Pascal's triangle. So we're taking it to the 4th. So row 4 of Pascal's triangle says that our coefficient should be what?
1, 4, 6, 4, 1.
1, 4, 6, 4, 1. So these are our coefficients. So now we'll start expanding it. So we'll take our first coefficient, which is 1, and then we're going to be multiplying by, we have x as our first term. So our first term starts out as what as exponent? Our first term. Our first term starts out to the power that we're taking it to and decreases. So we have x and we're taking it to the 4th. So we'll have x to the 4th. Now our second term is a 5. What does our second term start out with an exponent of? Our second term starts out with an exponent of 0 and increases. So our first term, the exponent decreases. The second term, the exponent increases. So this is our first term. Then we take our second coefficient. So we have 4. And that's times x to what power?
Third.
To the 3rd. And then our second term is 5. And what power is 5 to now? To the 1st. Then we take our next coefficient, multiply. X is to what power?
2.
Is squared. And our 5 is to what power?
2.
2. And then we take our next coefficient. X is to what power?
1.
To the 1st power. Our 5 is to what power?
4.
Our 5 is to what power?
3.
To 3. Because we had 2, so now we're at 3. And then our last term, we have a coefficient of 1. X is to what power? 0. And our 5 is to what power? 4. Now, if you notice, the exponents should add up to equal what it's being raised to. So here you have 4 plus 0 equals 4. 3 plus 1 equals 4. 2 plus 2 is 4. 1 and 3 is 4. And 0 and 4 is 4. So if your exponents don't add up to what power you're raising this to, one of them is wrong. They should always add up to the power that you're going to. So now we're going to simplify this expression. So we have 1 times x to the 4th times 5 to the 0. What's 5 to the 0? 1. So we have 1 times x to the 4th times 1, which is, so it's x to the 4th. Then our next term, we have 4 times x cubed times 5 to the 1. What's 5 to the 1?
5.
It's just 5. So we have two numbers that we can multiply out.
20.
4 times 5 is 20
X to
times x cubed. Then our next term, we have 6 times x squared times 5 squared. What's 5 squared?
the
It's
25.
25 times 6 is 150 times the x squared still. And then our next term, we have 5 cubed. What's 5 cubed? It's 125 times 4
500.
is 500. And that's times the x to the 1st. And then our last term, we have 1 times x to the 0 times 5 to the 4th. So we have 1 times x to the 0. What's x to the 0?
1.
1. So we have 1 times 1 times 5 to the 4th. What's 5 to the 4th?
625.
625. So this is our simplified expansion of x plus 5 to the 4th. And if you were doing this by hand, again, you would have x plus 5 times x plus 5 times x plus 5 times x plus 5. So wasn't this much quicker than doing this? So that's using Pascal's triangle. So now we're going to kind of generalize some of what we've talked about. So if we're looking at x plus y to the n, which would be, 1, 2, 3, whatever, to whatever power, our number of terms, if we look at our example right above, we have 1, 2, 3, 4, 5 terms. And we were taking it to the 4th. So our number of terms is one more than what we're taking the power of. So it's n plus 1. You should have one more term than what your power is. And then if we're looking at the exponents, your first term, for the first term, what was our exponent doing? Where was it starting? So it was starting at what you were taking a power of. So in this case, for our generalized case, it starts at n, so whatever your power is, it starts at that number, and it goes to 0. So the first term, the exponent is decreasing by 1 each term. Now your exponent for your second term. Where was our second term's exponent starting? It started at 0. And it went to the power that we were taking it to. So it goes to n. So our second term's exponent is increasing by 1 each term. And then our coefficients come from Pascal's triangle. Or by using combinations, which we're going to go over tomorrow. So right below this, the binomial theorem using Pascal's triangle is right here, where these P0, P1, P2 are your coefficients that come from Pascal's triangle, from whatever row you're looking at. So for homework, you're going to do the first 3 problems on the back page. It says lesson 11.8 worksheet. You're going to do the first 3 problems using Pascal's triangle to expand those.